All right, we need to start talking about density, so let's just jump right in. Our first essential question that we're going to look at today is how does a change in mass and or volume affect the density of an object? So let's start digging into that. So in order to talk about density, we need to know a couple of other terms. The first one is matter. So matter is a physical substance that is made up of particles and occupies space. So we are made of matter. Everything, your computer, your pencil that you're writing with, your notebook, everything that you can see and touch, everything that is a physical thing is made of matter. You guys probably know that there are three states of matter. Let me make my face a little smaller here. Three states of matter: solid, liquid, gas. In a solid, we usually have these kind of like lined up, almost crystal-like structures. Things are very orderly, and the particles aren't moving too much, and they're usually pretty tightly packed together. In a liquid, we still have pretty tightly packed particles, but they move around a little bit more. They kind of wiggle around and move around one another. And then with a gas, we have those moving, wiggling particles, but they are further apart from one another. So mass, we've talked about mass before. Mass is the measure of the amount of matter in an object. Okay, usually we'll use the unit grams to measure mass. Real quick, if we are in space, do we still have mass? The answer is yes, we do. A lot of people get confused because we are weightless in space. Things out in space don't have any weight to them, but that's because there's no gravity. They still have mass. They're still made of matter, right? Even if I'm an astronaut out in space, I still am made up of particles. I still have matter, right? So I still have mass. It's just that there's no gravity pulling me down, so I don't have any weight. But anyway, so units is grams, and the tool we usually use to measure these are balances, whether it's a digital balance, we've used those a couple times, or a triple beam balance. Next up is volume. So volume is the amount of space a thing takes up, literally just how big or small is it. The units we'll use are generally milliliters or cubic centimeters, and the tool, depending on what we're measuring, is a graduated cylinder or a ruler. So if we're doing liquid volume, we'll use a graduated cylinder, and that measures in milliliters. But if we're measuring something like a box or a cube, that's when we'll usually use cubic centimeters. And in order to measure that, maybe you guys remember doing length times width times height. That's why we'll use the ruler to measure the length and the width and the height. We'll multiply them together to find the volume. Finally, density. What is density? Well, it describes the relationship between a material's mass and its volume. The units we'll use are grams per milliliter or grams per cubic centimeter. It just depends on which volume unit we'll use in our calculation. Okay. Let's look at a couple of examples, and we'll kind of decide which of these cubes is more dense. So in this case, we've got the same volume with both cube A and cube B, but you'll notice that cube A has more stuff in it. There's more dots there. And in fact, they're more densely packed. In cube B, since we have fewer dots in that same amount of space, they're more further spread out. So in this case, cube A is going to be our more dense cube. Let's look at another example. In this case, their volumes are obviously different. Cube A is about twice as big as cube B, and in fact, they have the same amount of dots in them. Cube A is 5 across and 4 down. Cube B is 4 across and 5 down, so 20 dots in both boxes. But because cube A has a bigger volume, more space for those dots to spread out in, that means that cube B is more densely packed. So cube B is going to be our more dense cube. Let's look at one final example, and I'll slide my face over to this side. So in this case, we've got two different sized boxes, but we've also got two different numbers of dots inside of them. So this one, you could do the math and you could count, but really, if we kind of just look visually, the dots look pretty equally spread out in both cube A and cube B. So in this case, they're actually the same. Neither of them is more dense than the other one. So that's definitely a possibility. Density doesn't only have to do with how heavy a thing is, because if I have a big block of wood, it's going to be much heavier than a little tiny block of wood, right? But it's still the same material, so it's still going to have the same density. So that's what this is illustrating, is that it doesn't necessarily matter how big or how small something is. What matters is how much mass is in how much space. If there's a smaller space, you'll have less mass. If there's a bigger space, you'll have more mass. If you have the same density anyway. So let's recap what we learned. So how does a change in mass and or volume affect the density of an object? So we saw an example in the last slide where the mass increased, but the volume stayed the same. How did that affect the density of the object? When the mass increases, but the volume stays the same. Well, in that case, the object becomes more dense. So if the mass increases, but you don't have any more space to put it into, that mass has to be packed tighter into that same amount of space. So the object is going to become more dense. And then the flip side of that is if a object's volume increases, so it gets bigger, but the mass stays the same. Now I've got the same amount of matter, I've got the same amount of stuff, but now I've got a bigger space to spread out into. That's going to lower my density. That's when the object is going to become less dense. So hopefully this introduction to density kind of helps you understand at least the beginnings of what density is. Keep going through these videos and we'll dig even deeper into this topic. Hopefully this is a good introduction though.